Okay, welcome to my YouTube channel, and in this video we're going to look at mechanics, not the whole topic. That's in parts of mechanic. I'll be using a video for each part or each subtopic under mechanic. Mechanics in physics is a long topic, so it will take time. You cannot do it in one video. It will be a long video, to be like a movie, and that will be boring. It will be boring, so we'll cut it into part 1, part 2, part 3, just like that. So we start. Okay, so mechanics is a study of motion of objects. Mechanics is a study of the motion of objects. Kinematics is a science of describing the motion of objects using words, diagrams, numbers, graphs, and equations. Kinematics is a branch of mechanics. So we're not going to look at the whole mechanics. We're just going to look at a branch of it, which is what kinematics, it's a science used to describing the motion of objects using what words, diagrams, numbers, and graphs, and equations. So scalar quantity. Scalar quantity is a quantity which has magnitude with no direction. Scalar quantities can easily be added and subtracted. Examples of scalar quantities: we have distance, speed, mass, volume, and temperature. These are examples of what scalar quantities. Then we go to vectors. Vector quantity. Vector quantity is a quantity which has both magnitude and direction. So the only difference between vector quantity and scalar quantity is that scalar quantity has no direction, while vector quantity has direction. What is same between the scalar quantity and vector quantity is that they both have what magnitudes. So such question to come in the exam to differentiate or give the similarities between these two you need to know. This is the vector quantity. Vector quantities are mainly represented graphically or an arrow with a point. So it's how you represent a vector quantity. It's normally represented by an arrow, like the one I'm using here. The vector, so I can stop calling this an arrow, since you know that now it's what is a vector. Yeah, we can stop calling it an arrow, becoming into what a vector, since we both know that it's a vector. So vector quantities are mainly represented graphically or an arrow. I've already mentioned that. Vectors can be represented by in a particular direction, straight line with an arrow on a diagram. The length of the arrow is proportional to the magnitude size of a vector. That is, we choose a scale while the direction of the arrow is the direction of the vector. Examples of vector quantities: you have displacement, velocity, acceleration, force, weight, and momentum. So combination or addition of vectors. That's what we're going to look at. Several vectors can be added to get one resultant vector. The vectors which are added are called components of resultant vector. I hope we are clear here. The vectors which are added are called what? Components of resultant vectors. When adding vectors, the magnitude and direction of components has to be taken into consideration. There are two methods used when adding vectors. Suppose we are given vectors A and B shown below. Find the key. Let's look at the example I've been given, which is this one. have read, suppose we have vector A and B shown below. So this is our vector A. Like we said previously, that a vector can be presented like an arrow, which is vector A, which is vector B, and we're asked to find what the resultant. Okay. Number 1A, head to tail method. That's why we're going to use the method head to tail method to find what there is a resultant of these two vectors. Okay, so the method we're going to use is called head to tail. So when you say head to tail, it simply means you draw a set line. So this is the tail. Remember, this is the tail or that vector of vector A. This is the tail, and this is the head. So the method we're going to use is to join these two. You go at the tail of that vector, you draw a set line, then you go at the head of that vector, then you draw a set line where they are meeting. So it's important to measure a scale. You need to put a scale while you're doing this using the head and tail method. You need to have a scale. So now the resultant force to be this line here, same as the Pythagoras theorem. This one here, the hypotenuse. If you pay attention, if this was a right angled triangle, same applies to vector B. You go on the head, you draw a line, and you also go on the tail part there. You also draw a line starting from the tail until they meet. So after you have done this, that's how you use a head and tail method, just joining the head and the tail of a vector to find the resultant vector. So I'm going to mention method B, which is the parallelogram method. So what we do in the parallelogram method is simply join the tails of the two vectors and complete the parallelogram. What do I mean? For example, you have vector A here, from this one up to here. This arrow from here to here, this is what is vector A. Then this arrow from here up to here, this is vector B. So now you need to form a parallelogram. After forming a parallelogram, which means just on the after joining this, to make a straight line path, another straight line on the head of both vectors. After doing this, you join the arrows, the distance from the head to a head, that one you join it at one. After doing a parallelogram of those two vectors, what do? You need to draw a line cutting in the diagonal of this parallelogram. In this case, this is a FR. So the resultant force. That's how you find the resultant force using a parallelogram method. The resultant is a diagonal from the tails of the component vectors. As simple as that. When drawing the parallelogram, you go to the head. When drawing the resultant, you go to the tails of those vectors. As simple as that. Then go to combining. Done in combining vectors. You now go at adding vectors in the same direction. Okay. If a vector are acting in the same direction, find the or algebraic sum of the vectors. So what they mean is, when the vectors are going in the same direction, remember I said that vectors can be represented using arrows. So if the vectors are all moving in the same direction, what do? Just simply add all the algebraic expression. Algebraic expressions are simply numbers with the letters mixed together. So this is an algebraic expression, this is also an algebraic expression, this is also algebraic expression. If I go in the same direction, what do? Just add them. So you get f1 plus f2 plus f3. That will be what your resultant vector. Then go to vectors in the opposite direction. If the vectors are in the opposite direction, you need to find the difference, and the resultant is the direction of the larger vector. So here, looking at this diagram here, looking at these vectors here, you see that this vector 1 or f1 has a longer line than f2. So f2 here, you need to find the difference between this one and this one. So how do you find the difference? You need to subtract this one and this one, and the answer you get, that will be what? That will be your resultant vector, and the direction will be on the side where the vector is large. Obviously, just by looking at the arrows, you will be able to see that this one is bigger than this one. So hence, the object will move in this direction. Hope it's clear there. Okay, vectors acting perpendicular to each other. So how do you find vectors which are acting perpendicular to each other? How do you find the resultant force? If the vectors are perpendicular to each other, which is 90 degrees here, what do you use? You just simply use the Pythagoras theorem. Here we have f1 and f2, and use the Pythagoras theorem. It's as simple as that. Then we'll move on. Look at another concept, which is vectors which are not perpendicular to each other. What do we do? Okay, what do we do is simply, since here we need to find this resultant force, and you have a vector 1 here and a vector 2 here, and obviously these two vectors will form an angle, which is theta in this case, which is here. So what do you use? You simply use the cosine rule. When vectors are not perpendicular to each other, what do you use? Use the cosine rule. When they are perpendicular, what do you use? The Pythagoras theorem. That's how you find the vectors which are not perpendicular to each other. Okay, let's look at examples now. So example number 1 here. Example number 1 simply says that find the resultant of 100 Newton and 150 Newton force acting at an angle of 120 degrees to each other. So obviously, when they give you an angle, you're supposed to know that, okay, so obviously it's not what? It's above 90 degrees, so it's not perpendicular. So we're going to use the cosine rule to find the resultant of these two vectors. One vector, the other one is a vector which is 100 newtons, the other one is 150 newtons. So here's the solution right here. If you want, you can draw those two vectors, but you need to keep in mind that one needs to be longer or larger than the one. The one which is going to be larger is one which will 100 Newton, and the one which is smaller, the one which is larger is one which is going to be 150 Newton. Then the one which is going to be small is one with 150 Newtons. So here we don't have F1 have been given, F2 have been given. Then you just use the cosine rule to calculate. The answer you get, that will be what? Your resultant vector. I hope it's clear, guys. Okay, thank you for watching my YouTube channel, this video. I hope it helps you to understand about vectors in physics.